Hello, everyone. You can't see me. Well, maybe you can actually. Hello, everybody. I'm Jayant from the developer program team. It's a pleasure to see you all today. And it is my pleasure to introduce Gianmarco from ARM and Dijant Desai from Meta. And today we have a really exciting session about Executorch and all the latest updates, and especially on the open small model. And without further ado, Dijant, Gian, we can go for it.
Okay, so perfect. Maybe I can introduce myself, and I give you the word after me if you want, if it is okay. So my name is John Marco. And I'm leading the generative AI effort in at ARM in Cambridge. And what I look at, I'm looking at the software strategy and also the performance optimization use case, everything related to generative AI. In particular on-device generative AI. And today we're going to talk a bit more about an incredible use case that we managed to deploy at the edge, on mobile, and also in the cloud, of course, with the help of Executorch. Digan, do you want to introduce yourself?
Yeah. Hello, everybody. I'm Digan. I hope my audio is clear. I work at Meta as a software engineer. I'm one of the performance leads at Executorch in Executorch team. I look at all sorts of model acceleration on device, CPU, GPU, NPUs. ARM CPUs are my favorite. I have long history of working on ARM CPUs. Gianmarco knows this. Love it. Executorch loves ARM CPU, as you will see. And that's it, I guess. We can. I don't want to spoil too much. We can get started with the content, I guess.
No, absolutely. I mean, we have worked quite a lot on performance optimizations in these during these years, and in particular also for the use case that we're gonna talk a bit more today. And this session will be a mixture of two presentations, both delivered at PyTorch conference. One about Executorch, and one about use case that we manage to accelerate in real time on mobile. We haven't honestly, I mean, we have a few slides, but I think it's good. Digan, do you want to start talking about Executorch just to set the scene, and we can move on to the use case after that?
Yeah, let me try to share my screen. Okay.
You can give a little coverage.
Yeah, I can probably cover a bit of the Executorch part. Okay. And by the way, if you have questions related to Executorch or audio generation, please, you can interrupt at any point in time. So it's not absolutely a problem. So Executorch is a framework, an AI framework that allow us to deploy AI models, in particular at the edge, on device. This framework has been optimized to run these models very efficiently on CPU, but also on other backends. And Digan will talk a bit more about what we have done, in particular on the ARM CPU, and in particular on the latest technology that we have recently announced, so the SME2 technology. So is Digan on? Yeah, perfect.
I'm trying to. Discord wanted to.
I was trying to simulate your voice, but I didn't manage.
That's why I was sounding so much better.
Go for it.
Yeah, all right. I can also share if you want. I don't know if this is the latest version. I think if it is the Google Drive, if you have refreshed it, it should be the latest version. So maybe next slide. Yeah, so I can talk to this one. And I want to keep the prepared commentary very limited so we can spend more time in question and answer. So I'll move through the slides fast. Feel free to raise hand if you have a question. But the whole point of the Executorch development and the philosophy is to provide users with PyTorch native experience. Other frameworks you might have used start from a PyTorch module and they do some kind of conversion, non-numerics preserving, or you have to leave the PyTorch ecosystem. It gets very hard to debug, especially with quantized model. With Executorch, we leverage the export from introduced in PyTorch 2.0, and then we lower it and get to a serialized artifact that we call it PTE, which is an Executorch binary, and you can deploy that on a variety of edge devices. Next slide, please. So this is like this very simple 1, 2, 3 on how to get your PyTorch model running on device of your choice. So in step 1, you start with the PyTorch model. That's the my model, and you can get an exported program. So this is in it's a standard API from PyTorch. Once you have this exported program, it's nothing but your NN module represented as exported graph, the FX graph. And you can inspect it just like you would do with any Python program. In second step, this is where Executorch gets involved. Here, when you lower it, your exported FX program to the device of your choice, you have to tell Executorch what is your target backend. So in this example, we are using XNNPAC, which is like a CPU accelerator developed at Google. We leverage that. We also collaborate with them. And here you will get a specialized PTE, which should run on almost any CPU. May it be server, may it be a Raspberry Pi or a latest Android phone, as you will see in the detail. Now in step 3, you take this PTE, which is think of it as an ELF file. You can move it to your device and you can give it to the Executorch runtime. And this runtime is in C++, it's highly portable, and you can just call like a forward method on your tensor, just like you would do in PyTorch, and you should get your output. It's like a very high level simplified overview of how to use Executorch in practice. Next slide, please. Yeah, so now we have a bunch of backends, as you can imagine, but here we'll be focusing on XNNPAC. So now XNNPAC, as I said, is developed at Google. However, it has Clyde AI as a further acceleration or even more highly tuned operator library, as Gianmarco will say. This is his sort of project. This is mainly for CPU acceleration on ARM devices. Next slide, please. Yeah, so the Executor just went through a 1.0 release, which is like a stable general availability. That implies we'll have more backward forward compatibility on the APIs, and we won't be like it will be stable and production ready, especially for ARM CPU, which is our focus. With 1.0, one of the main things we introduced is SME2. SME2 is, as Gianmarco will elaborate further, is the latest hardware extension for ARM CPUs. It's an instruction set extension, and that helps a lot, especially with GEMS, and that in turn helps a lot with large language models, which are like very hot these days. So we can go through the detail. Then there are more stuff we also did for 1.0. Next slide, please. Yeah, so this is sort of like a list of just a high level list of model you can run today on any ARM CPU through Executorch. And this list includes like regular text LLMs, your most standard LLMs from Hugging Face. You can also run multimodal, as Gianmarco will show like a really cool example with AudioGen. We can also do LoRa adapters. We also do like standard computer vision models. So it's quite a wide range of model support, and this is particularly well tested on ARM CPUs. So you can just download Executor 1.0 and try it. It should work on your Android phone or on your ARM CPU, wherever it is, server or on the MacBook. Next slide, please. So just a quick humble brag. With help from partners like Gianmarco, ARM, and others, we have been able to successfully shape Executorch in almost all Meta products. We also have integration with other frameworks, other startups. So this is sort of like we are growing fast. If you are interested in deploying Executorch in your product or adapting it for your production flows, please reach out to us here on Discord. We have PyTorch chat channel. You'll have links at the end. Next slide, please. Yeah, so what we are doing in 1.1, so we are pushing quality, we are increasing coverage on more backends, different hardware accelerators, also pushing performance on ARM CPUs. I'll be asking Gianmarco for all sorts of kernels. All obviously quantization, more SDKs. Yeah, we are also pushing into AI PCs, extending our reach from mobile towards server, and starting with the desktop as the first step with Metal and CUDA. Next slide. So let's dig really quickly into Executorch and ARM CPUs and how it works under the hood. So if you see this diagram, very high level diagram, we start with the PyTorch module, and as I said, we convert to PTE file. Then you give the PTE file to Executorch runtime. Executorch runtime is very simple instruction by instruction interpreter, right? One of the instructions is a delegate call. So delegate is nothing but this subgraph will be handled by some other runtime. So in this case, it's XML-Pack runtime. So XML-Pack gets this runtime, gets this subgraph, and looks at the instruction, say, hey, do the gem, for example. Now, this is inside XML-Pack, it chooses to run it on its own, or most likely on ARM CPU, it says, hey, Clyde AI, can you handle this gem for us? And then you get like really fast performance for all the latest acceleration, latest extension based on the device. It detects dynamically. For example, if you have a Raspberry Pi, it will run dot product instruction for gem. But if you have like the latest and greatest, it will run SME2 kernels, even for like a 4-bit gem for LLMs. Next slide, please. So I think, I don't know if you want to, but these are some demos for ARM CPUs. We ran Gemma 3.4b, which takes an input. So it's an input image and text, and it will summarize the image, like you can say what's in the image, and stuff like that. So I don't want us to play. We will share the slides if you are curious, or you can find it online. And maybe next slide. So this one is Voxtrol. So Voxtrol is this is audio. So you give it audio and a text. And our common example is like if you hey, what is this song, right? Or what this? Well, if you can translate or transcribe or stuff like that. So this also works on ARM CPU today. We have a demo Android app. This will go through Clyde AI. If you are running on like a latest phone, you will see a really good performance. Next slide. Yeah, so this is all I had. As I said earlier, I don't want to spend too much time here. And also I want to give time back to Gianmarco and also for question and answer. But if you're interested, please look at the documentation on PyTorch website. We have a GitHub repository. All contributions are welcome. If you can't contribute and if you run into issue, feel free to create an issue. We have a Discord channel. I should have put link here, but I can share it later and I share the slides. But feel free to reach out to us. Yeah, over to you, Gianmarco.
Thanks a lot. I mean, it was super clear as usual. So I think Digan gave a very good overview about Executorch, the features supported by this framework, the ecosystem, but also said an important thing, right? So because we discussed about a use case to run on mobile, right? But Executorch is not just for mobile; it can run basically everywhere. And during my presentation at PyTorch conference, the title was Deploying AudioGen on Mobile, but the second slide was about trying to deploy these applications everywhere with very good performance, okay, through Executorch. So, and maybe I can share my slides as well, so I can segue, unless there are questions related to this part.
Do have one about, do we have any Windows on ARM demos?
Windows on ARM demos. Digan, do you have any demos?
So we have a CI, Windows plus x86. I believe we are working on Windows plus ARM. So are you looking at a developer setup or deployment setup?
Demos of usage.
So deployment, right? Yeah, I can get back to you. I don't think we have it today, but it shouldn't be terribly hard given we have Windows plus x86 in the CI. So yeah, feel free to drop a message either or create an issue on GitHub. We can definitely look into it.
Okay, cool. I think I can probably continue on. Okay, let me start sharing my screen. No, oh, it's not. Maybe I'm gonna wait other 10 minutes. One second. But hopefully not. Hopefully not. Hopefully not. So let me see. Share my screen. PyTorch conference. Share. And slideshow from beginning. I think you can see my slide.
With that, yeah.
Perfect, perfect.
Yeah.
Okay. And yes, the title of this presentation was saying is Gen AI for audio generation on mobile CPUs. I used the word mobile, right? But actually, the second slide of my presentation was not about mobile at all, because it was a story, or let's say the story of the presentation was about achieving outstanding performance across different diverse platforms and devices, from mobile to the cloud, with Executorch and ArmCloud AI. So, and in summary, this is a story about optimize once and deploy everywhere. So why did I use the word mobile in the title? And actually, the second slide of this presentation was about everything. So, because if you are a mobile developer, you probably have in front of you always the same problem. You want to test your application, your AI application. You also want to have an estimate about the performance you can achieve on mobile. Okay, and in some cases, you don't want to plug your mobile, okay, to your laptop. You want something easier, okay, to estimate its performance. And this is actually the story that I presented at PyTorch, because in some cases you can easily get an estimate about the performance by running the same code with Executorch, for instance, in the cloud, using maybe an ARM instance with a few CPUs. You don't need a lot of ARM CPUs. You can use, for instance, 4 CPUs just to have the sense of performance you can achieve on mobile, or on an ARM-based laptops, okay? Without changing the model, without changing the source code. You just need to compile for your specific target, and you can have an estimate. And this is actually a crucial feature of Executorch that honestly, I love it. I skipped this slide. This slide was actually a recap from the PyTorch conference from last year. I presented at the Generative AI Story on Mobile. It was about LLMs in particular, but this year we had something new, something also something big, I would say, because we managed to demonstrate audio generation mobile, and you can think about audio generation for many different use cases, from media creation directly on your device without internet connectivity. You can use, for instance, this model to create ringtones, for instance, using AI. And the beauty of this model is that every time you use the same prompt, you also generate different audio samples. Okay, so this is generative AI, right, in this sense, because there is a bit of randomness as well in the execution. It actually makes a very, very interesting use case.
We have a question, actually.
Go for it.
Does that mean Executorch can parallelize the execution on multiple cores?
Absolutely. I can answer this question, but I'd like to give Digant the opportunity to answer this question.
Digant is typing away, so we should have an answer soon.
Okay.
Yeah, I was typing. I didn't want to interrupt you. But yes, the answer is yes. We use multiple threads to parallelize. This is the data parallelism. So we don't run multiple operators in parallel because typically that level of parallelism is very limited in a neural network. But what we choose is the data level parallelism. So for example, a given operator, like think of a big matrix multiplication, that gets split into multiple threads, and each thread calculates a tile and stuff like that.
And believe it or not, I also have a slide with performance scaling on different number of cores, so using Executorch, running on different platforms. So absolutely. So you can talk about Cloud AI very, very simply. Cloud AI is a library that contains critical operators highly optimized for ARM CPUs. It's not just about a library just for generative AI. It's a library for AI workloads in general, so generative AI, or also for convolutional neural network based models. It is a library for framework developers. What does it mean if you are not a framework developer? Well, believe it or not, this library is already integrated and enabled by default in many, many frameworks already. Executorch is an example, is already integrated, is already enabled, so you don't need to specify anything. Okay? There are no dependencies. As I said, is that it has also permissive Apache 2 license, so you can take it and plug it in your framework. If you have a closed source framework, the library has been designed to be easily integrated in different frameworks that they want to leverage the CPU acceleration. So, and this is actually the Cloud AI integration. So, if from an application point of view, you are not exposed to Cloud AI because Cloud AI is already enabled by default. So this is already integrating different frameworks: Executorch, LightRT, Llama.cpp, MNN, Whisper.cpp. All of these frameworks, they have already Cloud AI enabled by default. And Cloud AI has optimizations for different CPU technologies. It's not just about Neon, but also nowadays for the latest SME2 technology, where I'm going to share a bit more in a bit. This is the demo I was mentioning earlier. It was a demo in collaboration with Stability AI. If you don't know Stability AI, this is the company behind the Stable Diffusion model, so the model that can generate images from prompt. But I also have an open model called Stable Audio Open Small, and we managed successfully together to make it smaller in order to run in, let's say, in real time on your mobile phone. Because what we have observed, we can generate 11 seconds of audio samples of different genres. For instance, loops for DJ consoles or sound effects for creating your media content in just 7 seconds on average mobile phones, or in 4 seconds if you have the SME2 acceleration. And that is the thing about, because most of the time, if you're a developer, you have to answer the question about, should I run on mobile? Should I run in the cloud? Okay. And well, there is not an answer that fit all the possible scenarios, right? It truly depends on the use case you're trying to target. For this specific use case, this is a use case where we don't think that with the first prompt you will be able actually to get the best sample, right? It is an iterative process, especially if you want to create a media content. And so having something local that can run on mobile, it reduces the interaction with the cloud. So you don't basically need to send any request to the cloud. Everything remains local. And also it allows you to generate also these contents without the internet connectivity, which is in some cases impossible to have. But there are scenarios where actually the cloud is important. Cloud in the sense that complementary to the on-device AI story. For instance, there are scenarios where you cannot achieve the same level of some level of performance that you expect. Let me give an example. For instance, for this kind of use case, the kind of user experience that we expect is around 10 seconds, not more than 10 seconds for generating an audio sample. But you probably know that out there are a lot of mobile phones, all with different compute capabilities, right? And it's truly difficult in some cases to achieve, in particular if you need to target also very old mobile phones, right? Well, the cloud here can help a lot, because you can, for instance, deploy the same application, so the same code and the same model in an ARM-based instance in order to guarantee the same level of performance that you want to guarantee to the user. And it's actually the most compelling story about this use case, and also the thing I really like of Executorch. I mean, the fact that you can build the application for your mobile platform, or you can also build your application for an ARM-based instance in the cloud. So, and actually the synthesis, right? So from mobile to the cloud, you don't need to change the code. The code is the same. You have the same model. And remember, this is crucial because you have exactly the same model and you can run it everywhere. So that is the model, but I want to skip it because already on the internet there is already an explanation of the pipeline. But it's made of 3 different models. The conditioner, which is a TF5 model, it has the diffusion stage, the DIT, and the autoencoder, which is quite a big model that actually generates the raw audio data, okay, the audio sample. It is something, the DIT is something that you need to generate several times. In this case, it's the number of steps is equal to 8 in order to generate very audio quality. And by the way, I think I forgot about the audio quality. What kind of audio samples we generate? I told you 11 seconds of audio, but it's also very good because it is with 44 kilohertz with stereophonic effect. So we are talking about very good audio samples. These are not mono audio samples. These are very, very good that you can also use, as I said, for media creation. What kind of optimizations did we apply to deploy this model efficiently on mobile? So first of all, the goal for us was to deploy this model without quantization-aware training techniques. Okay, we wanted to take the model and simply deploy it. This is a case where it is not easy to use integer 8 or quantization techniques or low numerical precision techniques in all blocks, because you are dealing with audio, and dealing with low numerical precision can compromise the audio quality because you can have artifacts in your audio samples. What we have found with Stability AI is that the DIT can be with int8 quantization, dynamic quantization, which means that the activations or the input of matmults are in floating point 32, but the weights are statically quantized to int8 with per channel quantization. Therefore, the floating pointer to input is dynamically quantized at runtime every time to int8 to perform an int8 by int8 multiple. The autoencoder instead has been converted to floating point 16. So we have found that actually this is 2x faster than FP32, and it was a good data type to preserve the quality of the autoencoder. We also mentioned in the paper that we wrote together that it's possible also to use integer 8, but it is a bit more complicated because you need to be careful on what layers actually you quantize to integer 8. The tutorial is available online, is open source. I actually, I also know that some developers already took the audio sample, the sample code for customize it or for hosting also the models on Hugging Face. So very, very good. I'm super happy. And if you have questions or you want to expand it, I mean, please. Is there a question?
Yes.
Go for it.
So if I have a local ARM Ampere test server, this is good for this is good for testing mobile apps on Ubuntu.
The answer is absolutely yes. So you need to consider that for sure your mobile platform won't have a lot of CPU cores. You're going to have maybe 4 up to 8 CPU cores. So when you run on this application on your ARM-based server instance, you need just to limit the number of CPU cores to use in order to have, let's say, an estimate about the performance. This doesn't mean you're going to match exactly the performance, but this will give you the sense about what kind of performance I can achieve on mobile. And maybe we can jump straight to the performance, right? Because there are already a few questions about what kind of performance we can achieve. It does a scale, Executorch, absolutely. So at the top, there are the performance measured on a mobile platform without SME. And you can see that between 1 core and 4 cores, okay, we move from 16 seconds to 8.4, which is absolutely a quite good performance for the use case we are targeting. But at the bottom, we have done the same on Graviton 4, so an ARM-based instance. As you can see, the performance is scaling, I would say, very, very well, because on 16 cores, you can run this use case in 2.2 seconds. Are there any questions?
Currently no.
No.
Just yes. No.
Perfect. Okay. So as I said, the same code, you just need to change your CMake command, because in one case you are cross-compiling. So if you're cross-compiling for Android, you need to provide the toolchain CMake file and also to specify the Android ABI. But apart from that, the CMake instruction, the CMake command is absolutely the same on Linux. What about SME2? So Digan introduced SME2 in his introduction about Executorch. And SME2 technology is a new technology in the ARMv9 CPU architecture that has been integrated to improve the performance, but to also give flexibility and the software programmability that developers want, okay, when they want to deploy AI workloads. Is basically, I really like this technology because my background is on software performance optimizations, and using these the SME2 technology, it means that I don't need to change my mindset to optimize the things. It's exactly the same. The performance are absolutely amazing. We will see in a bit. So if you're familiar with Neon instruction, Neon assembly, or SV in particular, well, you don't need to be worried because it's absolutely very, very, very similar. With the addition of some instructions that you will find extremely beneficial, in particular for matrix multiplication. And this is the key, I would say, the most important instruction that we have on the SME2, is MOPA, the matrix auto product accumulate. I don't want to jump into the details. I don't want to Otherwise, you're gonna all sleep after this presentation. I'm pretty sure. But in short, you can combine different MOPA instructions to perform a matrix multiplication. And here there is the assembly. At the bottom of the slide, you have an example of use of this instruction. What you need to remember is the fact that this instruction is available for many data types. It's not just for int8. It's also for floating point 16, int8. And combined with another instruction that I personally love it, which is the LUTI instruction, which is not in this slide, but it's called LUTI, which stands for look at table instruction. You can also leverage very efficiently integer for arithmetic, and also, for instance, perform the FP4 computation very efficiently, which is now a very hot topic nowadays. So let me go to the performance with the SME with SME2, and here I'm reporting a performance on the laptop because, as I said, well, SME2 is available nowadays also on mobile. But if you want to have an estimate, well, a good estimate can be achieved on your laptop if you have, for instance, one of the recent Apple platforms. And these are the level of performance on single core. So already with one core, you can achieve around 7 seconds of execution, which is absolutely a very strong story for SME. What about if I use multiple threads? You can go below 4 seconds, okay? But already with one CPU core, you can achieve outstanding performance. Yes, as I said, yes, this technology is already available on Android and iOS devices, so it's absolutely something that you should consider. If you're using Cloud AI, in Cloud AI we already have quite a lot of optimizations with SME2. And that's it. I would say let's leave for the questions. What do you think?
Yeah, no, amazing detail. Thank you so much, Gianmarco. It's been classic, exciting presentation, and I think the difference in time and performance is just staggering, and it's just amazing to see how SME2 and things like that enable it. We do have a question flying in. Does SME2 just require, is it a software upgrade, or is there specific hardware upgrade required?
Okay, so you need the hardware. So how does it work? So the SME. So how do we dispatch SME2 optimizations? Tigan, do you want to provide this answer, or I can answer? It's up to you. You can answer this question. How you delegate? Yeah.
Sure. So SME2 is a new hardware instruction. So that you need newer phone, for example, to be able to run this kernel Gianmarco just mentioned. But yeah, so that I mentioned earlier, Executorch dispatches this gem instruction to XML say, hey, do this matrix multiplication. XML looks into the CPU architecture system register saying, hey, do you have SME2? If it says yes, then we select the kernel which complies with that ID register and run that particular kernel. But if you're running on a Raspberry Pi, for example, which doesn't have SME2 hardware, then it will not run, and you transparently switch to something else like a dot product. So it's like it will pick the best on your platform.
I mean, this is the beauty also when you export the model, because the model when you when you export the model with the XNM pack partitioner, so you're basically not limiting the model to a specific hardware. Okay, so you're making the model compatible with basically all ARM CPUs. Okay, and therefore you build your application, and at runtime, basically you have the selection of the right optimizations, which is, in my opinion, one of the most important features of Executorch.
Amazing, thank you. We do have a follow-up question. Did a quick search and saw that Clyde AI support has been added to ONNX runtime. Is there anything extra that has to be done to ensure Clyde AI is being used, or is it automatically optimized out of the box for CPU models in ONNX runtime?
Okay, very good question. So we already have some optimizations also there. Certainly, I mean, you probably know that there are so many models out there, and this is true, and that can be deployed with different frameworks. Having an input from developers is crucial to understand where we need to land the next optimizations, right? So of course, we are targeting some optimizations, in particular for generative AI and also for some CNN-based models. But if you identify some inefficiency because some operators do not optimize in either Executorch or on an X runtime, you can let us know, and we can certainly try to work with our framework developers.
Amazing, thank you. And we've got another question. Just curious, does Clyde AI offer any pre/post processing APIs as well for general compute, like image resizing, warp, etc.?
I actually want to thank you for this question because I mentioned Clyde AI, but there is also Clyde CV. Okay, so Clyde CV is our library for computer vision routines. So this type of routine, which is absolutely crucial if you are developing a vision-based application, is available there and optimized for SME2.
CV. We will post a link in the chat later so you can dive into that and explore all of what it offers.
Yeah.
And yes, the floor is open. Please do keep the questions coming if you have any more. And yeah, now it's just very much an open discussion. We've got a few coming.
I just want to add for the Onyx runtime question. For Executorch, Clyde and in consequence, SME2 kernels are enabled by default. So if you just download Executorch and try to build it for Android phone, for example, you don't have to do anything separate like Gianmarco highlighted for the CMake command. It should just pick up the best kernel available. And another thing I want to highlight, which is quite recent development, is for LLMs, we use, just because the weights are so large, we use a special 4-bit integer quantization schema. And thanks to Gianmarco and team, now we have SME2 variant for that, SME2 kernel variant for that quantization schema. And that should give really good performance improvement if you are running LLM on device.
That's a very thanks a lot, Digan, actually, to highlight this aspect because there is an open merge
Yeah.
Clyde AI for the integer for Matmul with SME2 for Executorch. We can't wait actually to integrate it in Executorch.
We have the AM, so you all support SME2, or is that too old at this point? Is AM a specific architecture? Deep C1, please type. Ampere.
No, it's not available there.
Is are there plans too?
I don't know.
Okay, fair enough. All right. Right. Okay. So drive safely, Deep C1. Hope you get to your destination. And yes, please keep the questions coming. Aaron, I saw you typing. There we go. If I wanted to try ketchup, is ketchup a particular?
It seems like a typo. Yeah, I can. Hey, Aaron. Thank you for your interest. I'll definitely share Executorch documentation. Yeah.
All right. Yes. Please do keep an eye on the Discord server and the chats, and we will chuck in a bunch of resources and links which you can follow up with and learn more. Additionally, you can ping us on the Discord server anytime, and we can come answer any questions you have. Yes, there's so much reading. ARM really is the best rabbit hole you can find. So much out there to learn, and
yeah, what I can recommend is the guy. I mean, the AudioGen sample. It's very easy to be built and also to be executed on your target platform, because it's just a single file, CMake, and that's it. So you can test on different platforms, including Raspberry Pi, if you have enough RAM, because it's small, but of course, small is relative, right? Nowadays, because you still need at least 4 gigabytes of RAM for running this model. But if you have enough RAM, you can run also Raspberry Pi.
Amazing. If just going to give a minute or two for any further questions that come through. But in the meantime, thank you so much, Ian,
Thanks.
Marco. Thank you so much to John for coming on today. It's been a really educational and exciting session for all of us to learn just how far we've come, and it's exciting to see where we're going as well. And next year we could see even more power, performance optimizations, and all the goodness that everyone here can test out right away on your device from cloud to edge. So yes, thank you all so much for coming today.
Thanks a lot for inviting us.
Awesome.
Thank you.
I will see you all soon. This has been a great one. Thanks, everyone.
Thanks a lot,
Bye-bye.
Digant.
Yeah, bye. Thank
Bye-bye.
you, guys.